Okay, welcome everybody. We got an interesting question. We are expected to find the radius of the circle. So foremost we need the circle. So let me draw the circle. Okay, fair enough. Okay, so this is the center of the circle. Now we have an inscribed angle being created by this particular chord. So let me draw the chord. Okay, fair enough. And there is another inscribed angle that is being created. Probably the so figure is not to scale. This does not pass through the center. Okay, so you will have to make that sure. It does not pass through the center. So this is how it looks, because if it passes through the center it will become the diameter. So this does not pass through the center. Okay, so the center is outside. So let me spot that out. That's the center. Okay, so we have the point P, and this entire angle is created equal. Okay, so that means the division is equally performed here. Okay, so that is an important point. Now this length is 5 units, this length is 7 units, and this length is 3 times root of 5 units. So with all this information we are expected to find the radius of the circle. Okay, so let me name these points as Q, R and S. So having given you this information, let me start off. Now as I mentioned to you, this division is actually equal. So if I were to take this as, say, sum U, then the same angle U is created here. Okay, so QR will be the chord that subtends the angle U. Okay, so let me write that down. QR is the chord that subtends the angle say U. Okay, so if that be the situation, then this means U is an inscribed angle. Okay, now since U is an inscribed angle, so I just mentioned here, this means U is an inscribed angle, right? Because U is an inscribed angle, it will create an angle of length being equal to 2u. So this length created by the inscribed angle will be of length 2u. So similarly, this is also going to be u. As I mentioned to you, the angle over here and the angle over here are one and the same. So this is also going to be of length 2u. Okay. Now what I want to do is I would like to actually connect O with Q and O with R. So let me give a dashed line. O with Q and O with R. Now this is going to be the radii. Okay. Now this is the arc QR that is creating a central angle at O. We observe that arc QR subtends an angle at O. This will be of the same magnitude. So this means angle at O will also be equal to 2 times u. So this angle is 2 times u. So this angle RS, right, the arc RS will also create the same 2u. So if I were to draw the triangle, this is a triangle and I've got another triangle. So this is O, this is the arc QR, this is the arc RS. So this is actually creating a central angle of 2 times u, and this will also create a central angle of 2 times u. Right? Now this is R, this is R, this is R, this is R. So clearly we see that triangle QOR and triangle ROS are actually congruent. So this means QR distance will be same as RS distance. So we can take this as X and the same X will occur here. The same X will be occurring in both the sides. Now that is very, very critical. Okay. So now what I'm going to do is I would want to set up a system with X, an equation with X. So I will draw the triangle. I'm going to draw the triangle that we have. So this is the triangle. And this is Q, this is P, this is R, this is 5 units, this is 3 times the root of 5, this is X, and this is U. Now we will apply the cosine rule, which is written as this distance X squared is equal to 5 squared positive 3 times the root of 5 squared negative 2 times 5 times 3 times root of 5 multiplied with cos of this angle u. Okay, so I will have to place that angle. Okay, so this is for triangle PQR. Now there is another triangle PRS, right? So I'm going to set up a similar system. So this is going to be P, this is going to be R, this is going to be S, this is 3 times the root of 5. This distance is 7 units, this is U, this is X. Okay, so I have X squared is equal to 3 times the root of 5 squared positive 7 squared negative 2 times 3 times the root of 5 times 7 times cos u. So you subtract both the systems. So what do you get? You have x squared getting cancelled. You have say, if you had to equate and subtract on one side, okay, I'm going to write it like this. Okay, so this is going to be 5 squared positive 3 times the root of 5 squared negative 2 times 5 times 3 times the root of 5 times cos of u is equal to 3 times the root of 5 squared positive 7 squared negative 2 times 3 times the root of 5 times 7 times cos u. Okay, we can set up the system like this. Can we cancel? We can cancel this with this, and you have 5 squared. I'm going to write it, I'm going to push the 7 squared to this side, and I will bring this 2 times 5 times 3 times the root of 5 times cos u negative 2 times 3 times root of 5 times 7 times cos u. So this is what we got. So we have 25 negative 49 equal to 2 times of 5 times 3 times the root of 5 times cos u negative 2 times 3 times the root of 5 times 7 times of cos u. So from 49 we take away 25, we get, from 9 you take away 5, you have 4, and then from 4 you take away 2, you get 24 negative sign. So 3 times root 5 can be taken out, and you have a 2 there that can be taken out. Cos u can be taken out, so you have 5 negative 7. 5 negative 7 will give us negative 2 times 2 times 3 times root of 5 times cos of u. On the left you have negative 24. So negative positive 2 divides 24 12 times. This 2 divides 12 6 times. So you have 6 is equal to 3 times the root of 5 times cos u. 3 divides 6 2 times. So 2 over root of 5 is equal to cos u. Now I'm going to take this and substitute it in x squared is equal to 5 squared positive 3 times the root of 5 squared negative 2 times of 5 times of 3 times of root of 5, and cos u is 2 over root 5. I'm going to substitute it here. That's the first system that we created. You see here, this is a system. I'm substituting it over there. So root of I gets cancelled. So this gives you 5 squared 25. Root of 5 squared is 5, and 3 squared is 9. Negative 2 times 5 10. 10 times 30 times 2. That's going to be 60. Over here it's positive. So this is 25 plus 45 negative 60. So 45 added with 25 gives us 10 and 7. 70 negative 60, that's going to be 10. So x squared is equal to 10 units. This means x is equal to root of 10. Okay, that's a nice value. Okay, now we need to get the sine equivalent here. Now let me draw the triangle. Now this is going to be my u, and cos u is given to be as adjacent side divided by hypotenuse. So my hypotenuse is root of 5. My adjacent side is going to be 2. I need to get the opposite side. So if I were to take this as, say, some LMN by Pythagoras, lm squared plus mn squared is equal to ln squared. So ln squared is root of y squared, mn squared is required, and lm squared is 2 squared. So mn squared is 5 negative 4, which is 1. Therefore mn is equal to root of 1, which is nothing but 1. So this is 1. So therefore sine u is opposite side divided by hypotenuse, which is 1 over root of 5. So we have got sine u value. Now we don't have to extract the angle u, we can just utilize it as it is. Now the all important part here is to connect the sine rule with the radius of the circle. Now if you were to see here, this x is already obtained, right? So what I'm going to do is I'm going to apply sine rule here. So this is going to be the length x divided by sine of u is equal to 2 times r. This is the standard formula connecting the sine rule with the radius of the circle when the triangle is inscribed inside the circle. So my x is already known, which is going to be root of I think we got the value as root of 10, and my sine u value is 1 over root 5, and this is equal to 2 times r. So 2 times r is equal to root of 5 times root of 10, and I'm going to rewrite this as 2 times 5, which is root of 5 times root of 2 times root of 5, which is nothing but 5 times root of 2. This is 2 times r. So r is equal to 5 times root of 2 divided by 2. Now root of 2 is 1.414, and 5 times the root of 2 is going to be, we have to just multiply the component together, right? So 1.414 multiplied with 5 divided by 2. 2 divides here 3 times 6 and 10, 5, 10, 3 and 0. So this is the radius of the circle.